Okay, welcome back. Hopefully you are watching this video at this point and you've already completed questions 16 and 17 so we can check kind of your knowledge of how to plug in the numbers we have here into our equation, excuse me. So hopefully we are looking here at question 16 with 3 seconds. How far would student 4 have walked? That simply means we need to take this 3 and we need to plug it in for the variable t and multiply it out. Okay, remember when the variable is next to the number, we simply have to multiply in that situation. Or we could go up to the table we just created and realize that at 3 seconds, student 4 will have walked 10.5 feet. All right, so the second one is a little trickier because we don't have 2.5 seconds on our chart. Now there's multiple ways to do that. Again, I can go back up to the table and infer what is halfway between 7 and 10.5, but I think just plugging it into our formula here and realizing that D will equal 3.5 times, oh, I better not use the X symbol just for algebraic sense, 3.5 times 2.5 to determine what D is going to be, how far student 4 will have traveled, the distance student 4 will have traveled after 2.5 seconds. All right, remember that we can't multiply mixed numbers without them being turned into improper fractions. So this one here should become 7.5. This one here should become 5.5. So as we multiply that straight across, it becomes 35 over 4. All right, and then I change or convert that back into a mixed number. I can pull 8 whole numbers out of 35. Pull 8 4s out of 35, excuse me. That leaves me with 3 left over, and my denominator stays the same. So in that case, after 2.5 seconds, student 4 will have traveled 8 3/4 feet. All right, so again, showing you how we can get that equation to make it a little easier than trying to, one, infer off of our chart, and we can maybe figure out that 8 3/4 is halfway between 7 and 10.5, or we could create a graph and we could go through that whole thing and figure out where the line crosses. But I think it's just easier to realize that if we have that formula, if we have that equation set up there, simply plugging those numbers into that will make that a much easier situation. All right, one last little piece here. I'm not going to go through the whole of this last page, but I do want to talk about that we got one more. Oops, this is not the one I want to go to. One more student here. All right. And now we've got the student who is, I went down too far, student 5, who's walking at a constant rate of 11 feet for every 3 seconds. Okay, says if the answer is greater than 1, write the answer as a mixed number, or as a whole number or a mixed number. Write an equation relating D and T for student 5. So essentially we are trying to create an equation with using the unit rate, got to figure out the unit rate of 11 feet per every 3 seconds. All right, so first thing I need to do is I need to figure out, I can table it up or I can figure out how I want to do this, but basically I need to end up dividing 11 by 3 to figure out how far this person is going to travel for each and every second. Remember, this is 11 feet divided by 3 seconds, but we want to end up with this being over a 1. Okay, or figure out what it would be for every individual second. Now, all I need to do for that is, again, convert it into a mixed number. So the distance traveled for a certain amount of time will be whatever 11 over 3 is as a mixed number. So how many 3's can I pull out of 11? I can pull 3 full 3's. After I do that, I've got 2 left over. My denominator stays the same. So the unit rate for student 5, he is going to walk, or she, the student, is going to walk 3 2/3 feet per second. So that is my equation that I'm using for that. Now I can use that equation to help me answer questions 19 and 20. All right, and again, I could go through and set up a whole table for it, but to me it seems pretty difficult to start skip counting by 3 2/3 all the way through to get down to 6 seconds, or eventually to get to 7.5 seconds, which again is not going to be a nice even number. So I really just want to start getting comfortable plugging in the time, the number of seconds for t, to figure out what the dependent variable, or d, will equal. Okay, and that's kind of the biggest point of this whole lesson, is to be able to take this and plug it into the formula. So for 19, I simply need to take 6 and plug it in for t. So this one is going to become d will equal 3 2/3 times 6. All right, same situation here. I'm going to convert this back now to my 11/3 times 6 over 1. That's going to get me to 66 over 3. Now, lucky enough for us, that goes in nice and evenly. 66 divided by 3 gets us to 22 feet. So after 6 seconds, student 5 will have traveled 22 feet based on that equation, okay, based on that unit rate. The next one, a little trickier again. Now I've got two mixed numbers. So d, the distance traveled by student 5 after 7.5 seconds, will be traveling at 3 2/3 feet times 7.5 seconds. I'm going to convert this back to its 11/3. This one's going to become 15 halves, or 15 over 2. There is a way for me to simplify first, just to make this problem a little easier. I can divide both these by 3 and get it to be this. So now we end up with 55 over 2. Not 15, excuse me, 55 over 2, because 11 times 5 is 15. Now, how many 2's can I pull out of 55, or how many halves are in 55? Well, if I go down to 54, half of that is 27, and then I'm left over with 1 over 2. So in this case, 27.5 feet will be traveled after 7.5 seconds for student 5. All right, so again, guys, whenever we're working with those mixed numbers, not exactly easy. We're bringing a lot of different factors, a lot of different things that we've studied this year back into play, but hopefully we can keep it straight. The biggest thing we want you to understand is, if we can set up that equation, if we can figure out that d is going to equal whatever time they walk times the unit rate, we're going to figure out the distance that that student traveled. In this case, it's students, but whatever that vehicle or whatever that constant might be. All right? Good luck on your assignment. I don't, again, believe there will be as many mixed numbers or decimal numbers in there, so I think it'll be a little easier assignment than what we did for this lesson. But good luck, and again, if you have any questions with how to do this, make sure you are contacting your teacher. Good luck, guys.